Hello everyone, this is our team Maximus. We are going to present case study on electric scooter. So myself Harshita Kadam and my group members are Darshan, Mayur and Tanishq. So this is our case study on electric scooter. So this is a summary. The company launched its first electric scooter 2 years ago, but currently ranks fourth in the market due to the customer dissatisfaction and the underwhelming sales. So key user complaints include poor performance on rough roads, long and unreliable charging, and outdated app notifications, a heavy vehicle body, and a cluttered app UI. Financially, the company is incurring a 10% loss per vehicle and aims to achieve a 10% profit margin and a 50% sales increase in the first 6 months of the new version's launch, all without raising the vehicle's price. To address these issues, the product and engineering team is tasked with revamping the scooter and its ecosystem. Operationally, the goal is to reduce the critical issues from 6 in the first version to 0. Alongside solving the core complaints, the company is also incorporating competitive features identified through the market analysis to enhance the user satisfaction and the brand position. So, what vehicle data should the app collect, and how can it use AIML to provide useful recommendations to the driver? So, these are the smart app intelligence and recommendations that are data to collect recommendations using AIML. So, first is the in the data to collect battery data, charges, cycles, temperature, in ride behavior, braking, speed routes. In location info, there are GPS, traffic, vehicle diagnostic, motor, tire pressures. In charging patterns, there are times and durations. In recommendations, there is battery health tips that is charged to 80%, eco driving tips, drive slower, predicting maintenance service alerts, route optimization that is faster routes, usage insights that is driving behavior, and third is the using AI model. Yes, it's possible. Predictive maintenance, forecast failures. The second is battery life prediction, estimate lifespan, individual feedback, riding advice, and fourth is the anomaly detection, identify risk.
So now let's talk about the evolution of electric vehicles and their future in next 10 years. So in early 19th century, EVs originated with basic electric garages showcasing early innovations in electric mobility. Second is the 1990s. After a period of decline, interest in EVs re-urged due to environmental concerns and technology progress. Third one is the 2020s. EVs became the mainstream with increased consumer acceptance, government incentives, and improved infrastructure. Fourth one is the 2030s. The future promises EVs with longer battery ranges and integrated autonomous driving capabilities. So now let's talk about the future of EVs. So first one is the solid state batteries, safer, lighter, and longer lasting batteries. Second one is the wireless charging, convenient charging technology which can help enhancing the user experience. Third one is the full autonomous vehicle, EVs capable of self-driving without human intervention, which can help to travel safely. So now let's move on to the next page. So the next page talks about the identify key businesses and engineering matrices for improvising the product based on customer complaints with reasons for their selection. So the first one is the business matrices, customer satisfaction, gauge user happiness and loyalty. Second is the sales growth and market share, tracks market position and feature success. Third one is the profit per unit, measures financial health and turnaround. Engineering matrices, battery efficiency and degradation, solves charging issues, app latency and cache rate, improves real-time sync and UX. So now let's move on to the next page. So now let's talk about the top 10 app features for electric scooters and then we will highlight the top 5 most useful of them. So first one is the navigation, second one is the remote lock or unlock, third one is the range estimate, fourth one is the charging station locator, fifth one is the alerts and notification, sixth one is the document storage, seventh is battery status, eighth one is service scheduling, nine is ride statistics, and 10th is theft tracking. So now let's talk about the top 5 most useful features. So first one is the navigation that will ensure safe and efficient routing, which is essential in urban environments. So second will be the battery status, helps users monitor battery levels, avoiding sudden power loss in mid-ride. Third one is the range estimate, provides insights into how far the scooter can go. Fourth one is the charging station locator. Assist in quickly finding nearby charging points, especially helpful in unfamiliar areas. Fifth one is the alerts and notification. Keeps rider updated with important real-time info such as maintenance reminders or safety warnings.
List of top 10 features you have selected, do a relative priority exercise to mark them from P1, P2, and then from 1 to 10 and explain what you have decided those priorities. So first one is future priority list, which one is P1, P2, and rank from 1 to 10. So first one is battery status, second one is range estimate, charging station locator, alerts and notifications, remote lock unlock, service scheduling, ride statistics, and document storage. So first one is battery status. The reason for it is quite to monitor charge levels and prevent sudden breakdowns during rides. So second one is range estimate. The reason for it is key to trip planning, helping reduce range anxiety among users. So third one is charging station locator. The reason for it is essential to quickly find nearby charging points, especially on longer trips. So next one is alert and notifications. So in it, reason is helps in timely communication in important updates and safety warnings. So next one is remote lock unlock. Reason adds security and convenience, but is not crucial for basic ride operations. Next one, ride statistics. Reason for it is useful for tracking ride history and performing performance, but secondary core ride functions. Number nine, that is list business matrices like revenue, profits, and sales growth alongside operational matrices like quality, delivery time, and issue reports to evaluate electric vehicle performance and align with company goals. First one is business matrices. So, in which the revenue and profit per unit, uh, first topic that is so measure financial health and viability. So second point is sales growth and market share. So track competitiveness and customer reach. Third one is customer satisfaction, which is the most important thing for customers as well as the company. So it was loyalty and feedback. Fourth one is customer retention rate reflects long-term satisfaction. Moving towards next point, that is operational matrices. So that is product quality scores, delivery time accuracy, warranty claims, and service cost, critical issue reports. So these matrices guide strategic improvements and align engineering focus with business goals.
So, moving towards our next question, that is, design a user-friendly tablet dashboard UI showing key data like speech, battery status, navigation, and notifications. Explain default features, touch interactions, navigations, and functions to ensure ease of use. So we have designed a tablet dashboard UI. So in which the default feature displayed are speedometer, battery status, navigation map, and notification panel. Also, we have added the touch interactions and navigation, such as when we swipe left or right, so it will switch the screen. So also we have given a tap options, such as we tap on right stats, so it will show our right stats. So long press custom shortcuts and two finger swipe down. So next one is ease of use focused. For easy use, we have used the minimalistic layout and dark and light modes, voice command supports, and smart suggestions.